Welcome to our second slide entitled Why a Bayesian Approach Makes Sense. Here you see some of the basic points of a frequentist regression on the left-hand side and some of the basic points of a Bayesian regression on the right-hand side. And one of the things that I'd point out with regard to the Bayesian regression is that the main output is the posterior distribution, which means we're actually going to graph the posterior distribution of the probabilities of any given outcome for any parameter in the model. And when we do that, I would just point out that is the actual probability of that outcome and how that outcome probability is distributed. And I would also point out that in a Bayesian hierarchical regression that we do, endogeneity is inherently modeled in that kind of model. Now, here we see an OLS pooled regression output for this data. And the first thing that jumps off the screen is the R squared here is very low. However, if you look at financial restructuring, organizational restructuring, so F restruct and restruct, you'll see that a p-value there is a very low p-value. We would say that those are significant. We could say the same thing about personnel. But all of the others appear to be not significant. So in a regular hypothesis testing kind of model, using frequentist statistics, we wouldn't put a lot of stock in this output. We would say that all of those other things really don't matter. Selling units, buying units, entering new markets, personnel changes, alliances, layoffs, so forth. They really don't matter. Now, in a pooled regression model, using a Bayesian approach, this is the basic model. And notice here that we're making the assumption that the impact of any X on any Y is identical for all the firms in the sample. So even though this is a Bayesian analysis, it's very much like an OLS analysis. And from that, we get these posterior distributions. What you see here is the posterior distribution for each one of the strategic actions in our sample. Now the red line in the middle would be 0, and then above that and below that are percentages of effect that each one of these actions would have on performance. And notice if you look at new products, for example, new products is centered right around 0. But if you look up 2 variables to financial restructuring, you'll see that that's positioned off to the right, suggesting that most of the time there's going to be a positive effect on performance of financial restructuring. Again, these are actual probabilities. This is the distribution of the probability. Now, here we are looking at interval estimates. So the circle would be akin to a point estimate, and the dark blue lines going out from that circle are the interval estimates, indicating that the probable effect lies within that interval. Now, here we're looking at a posterior distribution for the 2 that had the highest probability of being a positive effect. And also in the OLS regression, we saw that these were 2 that had very low p-values. So we would say these are significant. And the way we would interpret this is that for financial restructuring, there's a 92% chance that it's going to have a positive impact on returns. And for organizational restructuring, a 70% chance. And again, those are the actual probabilities. Now let's move on to our hierarchical model. In this hierarchical model, we are now allowing the impact of X on Y to differ based on the industry that they're in. And this is what really adds to the power of a Bayesian model, that we're able to model this in such a way that we're accounting for the fact that each firm is operating within an industry. That also allows us to say something about industry effect versus firm effect. Here you see a little bit of code, and in fact, this is most of the code. This is in R, and this does most of everything we need it to do, including the output. So I show you this to indicate that it's incredibly simple. Okay, this is the end of our second video, and we hope that you'll take the opportunity to watch the third video that talks a little bit about what a Bayesian approach tells us. Thank you.